Hi, my name is Chris Fields, and this is the physics of microwave ovens. In 1945, Percy Spencer accidentally discovered the heating effect of a high-power microwave beam. While using radar technology developed during World War II, Percy noticed that the radar set he was working on started to melt a candy bar that was in his pocket. The first foods that were deliberately cooked using this newfound technology was popcorn and an egg. In order to confirm his findings, Spencer fed microwaves from a magnetron into a metal box from which they had no way to escape. The microwaves quickly heated any food that was placed inside the box. The company that Spencer worked for, Raytheon, quickly filed a patent for a microwave cooking oven. The first commercially available microwave oven, named the Raider Range, was 6 feet tall, 750 pounds, and $52,809 adjusted for inflation. It wasn't until 1967 when microwave ovens became affordable and reasonably sized. Microwave ovens have since become an important part of every kitchen. In 2008, a research study found that 95% of kitchens in Australia contained a microwave oven and that 83% of them were used daily. Microwaves play an important role in my life because they allow me to quickly and efficiently reheat and cook various foods. Without them, I would not be able to leave for school in the morning as quickly as I am now, and I would have to waste countless minutes waiting for the oven to preheat. Microwave ovens use various concepts of physics to heat up your food in seconds. Before we understand how a microwave oven works, we need to understand how it heats your food. Microwave ovens use high-intensity electromagnetic waves to heat your food through a process called dielectric heating. Many molecules that are found inside food, such as water, are polar molecules. This means that these molecules have a partial positive charge at one end and a partial negative charge at the other. These molecules rotate back and forth as they try to align themselves with the alternating electric field. As these molecules vibrate millions of times a second, they collide with other nonpolar molecules and set them in motion. This energy is then dispersed throughout the food as heat. Now let's look at how a microwave oven works. Microwave ovens consist of 6 main components. They use a magnetron, a waveguide, a fan, a turntable, a metal cage, and a power supply. First, let's look at the magnetron. At the center of the magnetron, a heated metal rod acts as a cathode. Surrounding the cathode is a ring-shaped anode. The anode has holes in it called resonant cavities. A powerful magnet is placed underneath this whole setup in order to generate a strong magnetic field. When the magnetron is turned on, the electrons follow a curved path through the space between the cathode and anode due to the force exerted by both the magnetic and electric fields. We learned about how magnetic fields can exert a force on charged particles in Chapter 21. As the electrons zip past the cavities, they resonate and emit microwave radiation. This is similar to how sound waves are emitted when you blow across the open end of a bottle. In Chapter 13, we learned about resonance in terms of sound waves. The waveguide carries microwaves from the magnetron into the cooking chamber. It consists of a rectangular metal tube. The boundary of the rectangular tube results in standing waves. The creation of standing waves inside the waveguide is similar to the standing waves we made during the open-closed pipe lab. Because of the boundaries of the waveguide, there is a maximum wavelength that can be transported through the tube before energy is lost. If width is the greater of the two dimensions within the waveguide, then the longest wavelength that will propagate is found using the top equation, and the lowest frequency is found using the bottom equation. The magnetron generates a lot of heat, so in order to keep the microwave from overheating, a fan blows across the magnetron and cools the other components of the oven. Oftentimes the nodes and antinodes of the standing waves can create hot spots in the microwave and heat food unevenly. The addition of a turntable moves the food in and out of the hot spot. Without the turntable, some parts of the food would end up being burnt, while other parts would still be cool. The metal cage that encloses the cooking chamber is what allows the microwaves to be contained. Microwaves reflect off the sides of the chamber and are directed back towards the food. The microwaves that reflect off the metal walls behave in the same way that visible light does when it reflects off of a mirror. We learned about reflection in Chapter 14. A metal grid is placed in front of the glass door so that you can still see into the microwave as it cooks. The wavelength of the microwaves are too large to fit through the tiny holes in the grid, so they act just like the metal plates that make up the walls of the cooking chamber. That was the physics behind microwave ovens. Thanks for watching, and I hope you liked it.
Microwave song. So take whatever food you got, whatever we got we share. Far away from the great outdoors, we know we got nothing to fear, 'cause the microwave will always be there.